101. My name is Gregory Sivikoff, and I'm a professor at the University of Alberta. With me are Sharon Morsink, Jeanette Gladstone, Ross Lockwood, and Curtis Brown, who will be your guides throughout our voyages to understanding black holes. Black holes have always been at the center of my research. Since I was an undergraduate student, I have used and continue to use a wide range of telescopes, such as the James Webb Space Telescope, Hubble Space Telescope, Chandra X-ray Observatory, and the Very Large Array, to name a few. Combining observations from multiple facilities, I observe how black holes can eat nearby material and, somewhat surprisingly, let out some burps. It turns out that black holes are not the neatest dinner guests, and I want to know how black holes create the messy outflows that astronomers call jets and winds. I am constantly amazed about what we know about black holes. For instance, in the center of our own Milky Way galaxy, we know there's a supermassive black hole whose mass is millions of times that of a star. But we also estimate that throughout our Milky Way, there are around 100 million of much smaller black holes called stellar mass black holes. How are supermassive and stellar mass black holes similar? How do they differ? And what can we learn about one from the other? These are just some of the questions we will be looking at in this course.
Hello, my name is Sharon Morsink, and I am also a professor at the University of Alberta. I studied the insides of black holes when I completed my PhD in theoretical physics. Over the years, I've also studied gravitational waves and X-ray emission from black holes and neutron stars, both of which are dense, compact objects. Neutron stars often get confused with black holes, which is why it is important that we also study neutron stars in this course. I am fascinated by the force of gravity. How does gravity cause light to travel on curved paths? What could we learn about black holes using techniques like gravitational lensing, such as the famous pictures of the black hole shadow in the nearby galaxy M87? And why exactly are scientists so excited about gravitational waves from merging black holes and neutron stars?
Hi there, I'm Curtis. Some things you ought to know about me: when I'm not on my side hustle slinging plywood, I'm learning about black holes and studying engineering. I've been keen on learning about astrophysics since the very first time I watched my favorite science guy, Neil deGrasse Tyson. In my spare time, I make pipe cleaner mustaches and sit above the streets of Toronto in my palace of textbooks. My interest in black holes started in my undergraduate courses in astrophysics. We learned that black holes are the endpoint of stellar evolution for high-mass stars. What I'm curious to learn is how the mass of a star can create a gravitationally collapsed object, a black hole. I know it has something to do with the four-dimensional structure of spacetime, but the thing that I'm really interested in is learning why massive black holes are much safer for astronauts and spaceships to visit than very small black holes. I can't wait to get started. I'll see you in the stellar nursery.
Hi, I'm Ross. I earned a PhD in condensed matter physics relating to quantum mechanics. As a result, I'm interested in the theories about microscopic black holes and the effects caused by quantum mechanics like Hawking radiation. I'm excited about learning what happens inside of a black hole, what would happen to an astronaut and their equipment if they crossed the event horizon, and what you would see if you looked towards a black hole's singularity. What would happen to an astronaut and the information they were collecting if they crossed into a black hole? And what about the possibility of them escaping from the black hole? But I'm most excited to be one of your teachers throughout the course. I'll see you in a little bit when we begin talking about Newtonian gravity.
Hi there, my name is Jeanette Gladstone, and I'm looking forward to helping you learn more about black holes while sharing some of my sci-fi favorites. I also have a PhD, but mine is in black holes, or rather, in observing them. Yes, I spent 3 years of my life in the UK testing theories and ideas that had been put forward to explain a strangely bright class of black hole. I know that sounds a bit of an oxymoron, but it's true. At the end of those 3 years, I got to call myself Dr. Jeanette, and then moved across the pond to continue researching black holes here at the University of Alberta. My background means that my favourite sections lie towards the end of the course, so I'm hoping you'll stick around to modules 8 and 9 to find out how it's actually possible to look at and study black holes. I hope to help you find the answers to questions such as, how do astronomers look at a black hole? How do they study them? And what do they look like? And more. Thank you for coming on this journey with us through space and time, and I look forward to chatting with you again soon.
In this course, we will be exploring these questions using animations, demonstrations, interactive learning objects, food analogies, calculations, readings, discussions, and other activities. In order to learn about black holes, we should first take a look at how black holes are portrayed in popular culture.